In today's part, we'll start with the next concept of chemical thermodynamics, that is called as enthalpy, given by H. Enthalpy, as said in 11th also, we have seen some terms of enthalpy. Enthalpy is nothing but the total heat content of the system. Now, according to the expression, the definition of enthalpy is given. First, we'll see the expression H is equal to U plus PV. This is the expression for enthalpy. So, how is it defined? It is defined as summation of or sum of internal energy of the system and PV type of work done by the system. This is said to be enthalpy, and on the basis of expression for enthalpy, we have the definition of enthalpy as I just said now. So this is enthalpy H. Delta H is change in enthalpy, which is given as H2 minus H1. H1 becomes the initial enthalpy of the system and H2 becomes the final enthalpy. So from these two values, we can calculate the change in enthalpy of the system. Hence, we can say that delta H is a state function because it depends upon the initial state and final state of the system. Now, from enthalpy expression H is equal to U plus PV, I can find the mathematical expression for delta H. Now, how to find that? We are going towards that point. From the definition of enthalpy, H is equal to U plus PV. So, I can write H1 is equal to U1 plus P1 V1. How 1, 1, 1, 1 ka ghetla apan? Because we are going for the initial state of the system. So, initial state मध्ये enthalpy किती असेल? H1. So, H1 is equal to U1 plus P1 V1. In the final state of the system, enthalpy H1 changes to H2. So, H2 becomes equal to U2 plus P2 V2. So, I want to now find delta H. Delta H काय असेल? H2 minus H1. हे दोन expression minus करा. H2 minus H1. So, H2 minus H1 is equal to U2 plus P2 V2. हा आला minus U1 plus P1 V1. हा एक्सप्रेशन इथे आलेला. बुकनी मिस्टेक दिलेले आहेत म्हणून इथे करेक्शन करा, रेक्टिफाय करा. बुक इज गिविंग अ रॉंग say sign over here. You can see it in the book. So delta H, H2 minus H1 is delta H, which is equal to U2 plus P2 V2 as it is. Open the brackets, you will get minus U1 minus P1 V1. So combine U2 minus U1 plus P2 V2 minus P1 V1. U2 minus U1 becomes delta U, and P2 minus P1 can be written as delta P into V2 minus V1 can be written as delta V. Delta म्हणून बाहेर काढला and this is written as delta P into V. This is nothing but delta P into delta V. So delta बाहेर काढून you get P into V. So finally you get what? Delta H is equal to delta U plus delta P into V. Now if pressure is kept constant at constant pressure, you will find P1 is same as P2 is equal to P. So expression changes to delta H is equal to delta U plus P into delta V. Delta गेला because pressure constant आहे. Delta काय असतो? Change in pressure. But आपण काय म्हणतोय? Pressure is constant P. म्हणून we are just writing this as P and delta V change होणार because हा constant नाहीये. इथे pressure आपण constant घेतलाय P म्हणून delta sign गेला and P into delta V you get. This becomes the expression for change in enthalpy. So you get a question sometimes that derive the expression for change in enthalpy, which is like this. From here to here you are supposed to write that. The expression comes for 2 marks. Now in the same expression, in spite of writing delta H, I can also write it as QP. Q is nothing but the heat content. It is heat. So heat at constant pressure, QP. We are considering pressure as constant. So QP is equal to delta U plus P delta V. This can also be written. Why we are writing QP is mentioned here that delta H is same as QP. Heat at constant pressure. I said heat, enthalpy is nothing but the heat content of the system. So from this you can get it over here. Next part is to find relation between delta H and delta U. What is the relation between delta H and delta U? Now we are already familiar with the expression of delta H. that delta H is equal to delta U plus P delta V. So I can write delta H as delta U plus P into V2 minus V1. Delta V ला आपण substitute काय केलंय V2 minus V1. This is change in volume which is written as V2 minus V1. Now delta H is equal to delta U plus, multiply the bracket, open up the brackets, P into V2 minus P into V1. Now according to the general gas equation, as we know, at constant pressure, according to general gas equation, you will get the expression as PV1 is equal to N1 RT and PV2 is equal to N2 RT. What is constant? Pressure is kept constant. P1 V1 9. We will take it as PV1 and it is PV2. R is molar gas constant. T is constant here. This is at constant temperature. So P and T are constant terms. So substitute the value of PV2 and PV1 from the expressions here in the next part. So delta H is equal to delta U plus PV2 च्या place वरती टाका N2 RT minus PV1 च्या place वरती N1 RT. Substitute the values here. So delta H is equal to delta U as it is plus from these two terms. From these two terms you can find that RT and RT are constant. Take it out of the bracket. Inside the bracket you get N2 minus N1. So delta H is equal to delta U plus delta N. N2 minus N1 is delta N RT. Only the thing is, in spite of writing delta N, we are writing it as delta N G, because you are considering this system of a gaseous system. As we have considered general gas equation, we are considering a gaseous system, म्हणून हा G आलेला आहे. It is not a multiplication factor, पण तो symbol आहे Ng, where G stands for gas. So how do we write? Delta Ng is nothing but it is moles of the gaseous products minus moles of the gaseous reactants. Products आणि reactants चे moles हे आपण minus करणार. पण कुठले moles? Gaseous moles. बाकी state चे नाही, फक्त gaseous आपण consider करणार. That becomes delta G. That is change in number of moles.